So now we're going to look at how to create a heat map that we can display over Mapbox. And I found this website airnowapi.org, which gives you access to API which has air quality sensors all over the world. And so you can play. You can choose the type of format you want. And in that case, we're going to need JSON, and you can play with the different generated URLs and the type of output that they create depending on the region and a few other parameters. And I could not put that into the data URL node as we have done in the previous tutorial. But the reason is because as soon as you request the API, it actually is a redirect. So it will open the file which has the content of all the payload. So we're actually going to use a different node for that. We're going to copy that and we're going to create a data node, which is almost the same thing as a data URL, except we give it the data right away. So if I displayed it right away inside, we can see that I have the same attribute as the data URL was giving me. And as I display, I'm going to display it like that this time on a spreadsheet, you can see that we have all the values that we need. In that case, we are going to do the same thing as we have done before with the latitude and longitude. We're going to put them on the position. So I'm going to use the attribute copy again, the same way we have done before. In that case, just making sure about the spelling. So longitude with an uppercase, longitude, and a new name on the position, not to all components, so that will go to the Y. And I'm going to copy that and do it for the latitude. So now the little point that we are seeing here has disappeared because they all have different position. You can see that we have increased that. And I am going to, so latitude should go to the Z component. And now I'm going to center that so we can see where we are. And we can see that we have points that do look like they are scattered on the map. Now let me see if I open the spreadsheet again. I'll do that here, split vertical. Spreadsheet, what type of longitude and latitude we have. So I'm not exactly sure where this is, but I'm going to create a Mapbox camera regardless, and I'm going to locate that. So the values I have is -8742. So I'm going to go to the Mapbox camera, -8742, and I'm going to zoom out. The default zoom is quite heavy. Probably also remove the pitch, remove the bearing, and I can navigate with the mouse, and I am in North America. So now that's going to be the default position for our map. So I'm just going to put set default, so whenever I reload the file or the camera, then this will be the position we're going to start with. And now if I want to display those points, I'm going to use the Mapbox transform node, and I should see my points. Here you go, here they are. So I'm probably going to zoom out, zoom in, and I'm going to go back to the camera and say this is my default. So it will have changed those values here. So now let's convert those points into an actual heat map. So we have the points here, but I'm going to work on those from the perspective camera since it's easier. So I'll do it from this window. So that's my perspective. So now I can have both in next to each other, and I'm going to look at the plane, and I'm going to use that. So that will be a plane covering all the points, and I'm going to reduce the step size so I have a bit more resolution. And I want to transfer the attribute that we're interested in is the AQI. If I look at this one, it is this one. So I want to transfer this attribute onto the plane and have that affect the color. So first, if I look at the AQI values, if I look at it from here, and I can see that they go from 15 to 158, and I want to remap that from 0 to 1. It's going to be much easier to manipulate. So I'm going to use attribute normalize, and I'm going to type AQI, and now I can see that the values should go from 0 to 1. Now I'm going to use attribute transfer. I'm going to remove that to have a bit more space, delete, and that. attribute transfer, and I'm going to transfer the AQI from one to the other. So I remove color, I put AQI, and now it's not exactly, if I go back to the perspective camera, it's not the most visible, but I need to, because I need to put that onto the shader, so it will be actually visible. And so I'm going to create a material just for that. I'm going to put it on basic, and I'm going to assign it mesh basic, and now I'm going to, it's all white because that's the default, but I'm going to use the attribute AQI to blend, to drive the color. So it's going to be green when the AQI is low and 1 when it's high. So here you go, that's what we have. And now I can play with the values on the attribute transfer, because each point on this grid is going to look at the points that are here. Right now it only takes the closest one, but I probably want to use a bit more than that. I want to use maybe the 3 points nearby, and I can also define the nearest limit. So there is a bit of a blend, and maybe I'm also going to increase the, that's probably too high. No, not like this. And maybe I'm going to increase the step size, or lower the step size to increase the resolution. So that's what we have. So now let's put that on the map. So we're going to use a Mapbox transform again. And if I look from the perspective, so from the Mapbox camera, I should now see that. I do not see it, and the reason is because the plane is actually looking at the other way around. I need to make sure the plane is double-sided, which I'm going to do here. And I do not still see it, so let me check what could be the reason. Is that because, yes, because I was working on this node. So what I need to do is simply remove that, and now I can see it. It's covering the map. It should be good to have it transparent, so I'm just gonna put some transparency like this. So now I can see a proper heat map. But one limitation of that is that the heat map that we see is very static. The grid is not going to change resolution depending on our zoom level. We might want to have something like that. So what we can use instead of this plane, which is just constrained to the initial point, is to use the Mapbox plane. The Mapbox plane is going to show us a plane that is only bound to the viewport. So wherever we look, it will be just that viewport. So I'm going to make sure I don't delete the out of view points, and I do not, right now it's directly into the Mapbox viewport, into the Mapbox matrix, but I don't want that because it's going to be hard to transfer the point values. So I'm going to toggle that off, and which means I do not see it now, but I will put it back. If I put that back into the Mapbox transform later, then I see the same thing, I see this plane. But in between I will be able to do the operation. So I will just do that and then put it back in here. So now I should be able to see exactly that. And I'm going to reduce the resolution a little bit because it's a little heavy. But now I can see the heat map values. And every time I zoom, it will keep becoming denser and denser. So that's for the heat map itself. Now what would be interesting to have is to have tubes showing us a bit more variation on where the data changes, because right now it still feels very flat. So what we can do is try and instantiate tubes on each of the points of that plane. So let's try and do that. So I'm just going to drop a cylinder, and I'm going to use the instance node. So I won't be able to use the same material as I was having. I'll have to use a material specifically for the instance. So I'm going to put this here. That's not going to change. And I'm going to put the Mapbox transform before the instance, and I'm going to show the tubes there. So they probably are very big, which is why they're covering most of the screen. So I'm going to reduce the cylinder, and I should see all of them now. I'm going to put them at 6-sided, and it would be nice if it was actually hexagonal, so that the tubes would line up a bit nicer. So I'm actually going to make 2 different branches. So I'm going to keep this plane and keep that here, but I'm going to copy paste those 2, and instead of that plane where we're going to instantiate cylinder, instead of having it on plane mode, I'm going to have it on hexagon. So now we can see that our hexagon are going to be a bit nicer like this. I'm going to increase that resolution, and you can see that the hexagons are now matching the grid. Now what we want to do is the same thing we're having to drive the color here on this material. We're going to have it on the instance. So I'm going to go here to the Lambert instance, and I'm going to copy the attribute AQI into here and have that drive the color, not on this one, on this one. Now, just like in the previous tutorial, we need to make sure that the AQI is going to be passed, and we can see that we are having the colors which is being driven by that. Now we can also have the height of the tube that's going to be driven by that. So I'm going to go back into the into the material, and I'm going to have the scale is being driven by this. Right now it's picking up the default attribute, which is 1, but I'm going to use I'm going to overwrite it out. So I'm going to say instance scale. I'm going to take it as a float. So right now this is not going to change anything, but I'm going to multiply it by this attribute. And I just want to multiply the component, which is going to be the height. Everything, the x and y, I don't want to change them. So I'm going to put this as a mult add, so I can change this value. And I want that to affect the z component, so I'm going to take the float. I'm going to leave the x and y to 1, and I'm going to multiply that. Like this. So now we should see where the values are high. If I find those, we should see that we have already a height variation, and I'm going to increase that like this, so it's a bit more visible. And it's completely hiding the map, so we're going to change the opacity like this. So now we can have a better view of the map. But now we are losing everything, even the high point. So I think what I want to do is to not affect the opacity of the high point, but only have the low values disappear. So I'm going to put this back here, and instead I'm going to have the AQI plugged right into the alpha. Here you go. So now I can see that those are denser. And that's it. That allows us to have a map where the AQI values are driven by the color and the value of the AQI, and still allowing us to see the map under it.